Hello everyone, welcome to Breakfast Question, a special edition of Mathematics Meal. Don't mind my attire this morning. I rushed to the laboratory for an experiment and just discovered that I've not fed many people mathematically this morning, and that's why I decided to come here with my laboratory attire. I hope you wouldn't mind. All right, today on Breakfast Question, we are going to look at a question from Theory of Logarithm. It's necessary that you watch our videos on logarithm for you to understand the concept of logarithm. So we're going to solve this question as our breakfast question this morning. So follow me as we solve it together. All right, so let's solve. We're asked to evaluate log 4 in base root 2, log in base half, that's log 16 in base half minus 1 over 2 log 32 in base 2. Okay. Now we know that there are several methods of simplifying logarithmic expressions. There are. Now if we check this, the bases are not the same, so we can actually make the bases the same, or we can solve them singly, just 10 by 10 without combining them. It's still possible that we'll combine them by first of all making the bases to be the same, then we can now combine them using the first and second law of logarithm. But let's use the other approach by solving them 10 by 10, simplifying them 10 by 10 until we get rid of the log operator. So we have log 4 in base root 2 plus log 16 in base 1 over 2 minus 1 over 2 log 32 in base 2. I can start this way. I don't like this one being square root of 2, so I can write it in another form, and that is log 4 2 raised to power half. That's in base 2 raised to power half. Now 2 raised to power half is the same thing as square root of what? 2. Then I don't like this half, so I can write this as log 16 in base 2 raised to power minus 1. Sorry, what we have here is plus. Then I can still keep this like this, 1 over 2 log 32 base 2. Okay, my interest is this: if I can make the basis, the number and the base to be the same, then remember that logarithm of a number to its own base is 1. So if here I can have the base and the number as the same number, then I can actually get rid of the log operator. So that's my target. So let's see the possible laws that we can now apply. Now, when the power is on the base, it becomes the reciprocal of the coefficient of the log operator. But before then, let's see if we can reduce all this. I have 2 here. I can write this in 2s. I can write this in 2s. I can also write this in 2. That means the common ancestor of 4 and 2 is 2. So I can write this as log 2 raised to power 2 in base 2 raised to power half. Let's do that. Plus, this is log 2 raised to power 4 in base 2 raised to power minus 1. Then, sorry, this negative sign, let's not make that mistake. That's what we have in the equation. So minus 1 over 2 log 2 raised to power 5 in base 2. Okay? Now, I need to take away the power on the number and also the power on the word base. Now, when the power on the number, the power of the number when taken away is the same thing as the coefficient of the log. If the power is on the base, it's the same thing as the reciprocal of the what? Of the coefficient of the log. That means this, look at the law here, 2 raised to log p raised to power m in base n is something as saying m log p in base n, the power on the number becoming the coefficient of the log. But if I have log p raised to power m, then n in base n raised to power maybe r. This is something as saying 1 over r times m p log times m log p in base n. Now when the power is on the base, it's same thing as the reciprocal of the coefficient of the log. You see, when this arrow comes here, it becomes 1 over r. But when the power is on the number, it will not, it's just the same number that will multiply the what? The log. So if I do that here, this, the reciprocal of 1 over 2 is 2. This one still remains 2 log 2 base 2. Then plus reciprocal of minus 1 is still minus 1. Then times 4 log 2 base 2. Then I need to clean this. So create space minus the reciprocal. Okay, no power here, so I still have 1 over 2 now. Then the power here is 5 log 2 base 2. Now log 2 in base 2 is 1, so we have 2 times 2 times 1. Then plus, then this log 2 in base 2 is still 1. We have minus 1 times 4 times 1. Then minus 1 over 2 times 5 times 1, because log 2 in base 2 is still 1. So we have that. 2 times this is 4. This will give us minus 4. That will give us minus 5 over 2, because plus times minus is minus. 4 minus 4 is 0. 0 minus this will give us minus 5 all upon 2. That's the whole of this. That's the whole of this. All right. That's all for our breakfast question. Now, for you to understand more about the concept of theory of logarithm, there is every need for you to watch our videos on theory of logarithm. We have over 18 videos on this, on theory of logarithm alone. Just watch as many as possible, and then you will become so familiar and become so wonderful in solving questions on theory of logarithm. Till I come your way next time, continue to enjoy Mathematics Main. Oh, before I forget, remember there is need for you to subscribe to our YouTube channel. Thank you and God bless you.